Okay, good afternoon to everyone. I'm pleased to introduce Professor Raquel Hill from University of Indiana at Bloomington. So, go ahead.
Thank you, Elisa. Today I'm going to talk about plug-and-play trust for embedded communication systems. So there's always a lot of information in the title. So we're going to start by trying to, understand exactly what, I'm going to talk about just by looking at what's going on in the title. So the first thing that hits you is the notion of plug and play. And we always, given all the technology today that's plug and play, we're looking at something that's going to be automatic. So, when you're using these services that this work provides, we're looking at automatic trust, okay? We're going to actually break down the whole notion of what trust is, a little bit later in the presentation. But the other important thing to look at is that we're talking about embedded systems. And specifically, we're looking at communications between embedded systems. So when you're thinking about the type of systems that is being discussed or looked at in this work, think about a remote system where you want to verify the integrity of what's actually going on in the system. So when we're looking at trust, we're looking specifically at integrity-based trust. So whether the system state is in a configuration state that is equal to some pre-agreed upon certified state. So whether this certified state is trustworthy is outside of the scope of the work that we're looking at here, because that's a whole nother area of work to determine whether the system is in a trustworthy state. But here we're just looking at trying to verify the integrity. So we've agreed upon a set of criteria that constitute what we consider to be trusted state that can be certified by a third party as being trustworthy, and how to determine trustworthiness is outside of the scope of the work, but integrity is what we're looking at for trust. So certified integrity is what we're looking at here. So, and we want to be able to have a system and a platform that will do this automatically for us. Okay, so what is trust? So there are basically two different types of trust that we're looking at. One is the social trust that is based on the reputation and recommendation of the system, and the other is behavioral trust. Is that, can you prove that you meet certain criteria? And as it relates to this work, this criteria goes back to some pre-certified state, and that's the criteria you need to be able to prove that you meet. So that goes back to the integrity. And so what we're looking at here is more of the behavioral trust, and as it relates to the integrity of a system. But when we begin to talk about the hardware that we're using in order to facilitate this evaluation of trust, what we're going to see is that we also have to rely somewhat on social trust, because social trust in the vendors that are actually developing this hardware. So you can't get away from the social trust, but what we want to do is the behavioral trust and focus on the proof. Okay. So the behavioral trust expounded is basically just looking at, this notion of certified trust or integrity based trust. And so trusted doesn't always mean trustworthy, because that's a whole nother area of work. And trusted doesn't mean that there are no flaws. Okay, so just keep that in mind. So we are looking at something that is going to give us an automatic evaluation, of our notion of trust. Trust means integrity, and something that about a pre-certified state. Okay. Okay, so I have these blank screens here just to let me know, like, I'm transitioning now to the next topic. So we're going to look at the problem and motivation for this particular work. So why is it that I want to look at this problem of evaluating the integrity of a remote system? What we're finding now with the proliferation of malware, that systems are being compromised. We have systems from ATM machines, we have our routers, our infrastructure being compromised, electronic voting systems being compromised. And so, there's a need for just to evaluate the state of the system. Is the system in a state that I expect it to be in? And so this is what this work is actually looking at, and so compromise of such systems can really affect our faith in, these large area systems, especially when we're looking at things like the power grid, our banking institutions, and they may not just have a local effect, but a national and even an international effect on our trustworthiness of these, on our sense of trustworthiness of these systems. So that's why we're looking at this particular problem. And this problem became really interesting to me when I was reading articles earlier this year about the compromise of ATM machines. So earlier in 2009, there were some Eastern European banks that basically detected that their ATM machines contain malware that actually copied the magnetic strip of ATM cards. And so what would happen is that when the hacker actually came up and inserted a MasterCard, what he would get is all the receipts of all the ATM magnetic strips that had been copied. Okay, so, if we had a system in place where we could evaluate the integrity of, the software that's loaded on an ATM, if a banking institution, before it would actually process a request to, withdraw money, evaluate the state of that ATM and deny the request if the software that's running on the ATM is not what it expected to be, we could reduce the effects of compromised machines. Okay, so this is helps to motivate why are we actually concerned about the integrity of these systems. So our research question is how do I establish trust of a device that may be reconfigured? Reconfigured to provide a different set of functions. And, whether it's reconfigured intentionally or unintentionally. And how can we establish, evaluate, and maintain platform integrity? And so platforms perform as specified or expected. So expected here just means that you're running the software that I expect you to run, but doesn't necessarily say anything about whether this software has bugs or there are flaws or anything like that, but this is the expected software suite that that is expected. So the proposed solution is to use trusted computing platforms to enhance the security solutions and to evaluate integrity. So how many of you actually are familiar with trusted computing platforms in the room? Show of hands. There are a couple of you. Okay, I have sufficient background to begin to help you to understand like what a trusted computing platform is and how it can actually be used. Okay, so trusted computing technology is technology that allows a platform to give unforgeable guarantees about its configuration state. Okay, so what that actually says is that I want something that's unforgeable, which implies that there is some type of digital signature, okay, that's being used. So you got a hardware platform, you have a separate execution environment that's separate from the host that this chip is embedded in. It has its own separate storage. It also has its own identity-based cryptographic key. So you're using some public key cryptography here. And the private key is stored within the device itself. You will release the public key to some entity that can certify that this public key is associated with this particular trusted platform module. Okay, so we have this, so that's what makes it unforgeable. So how do we actually try to forge this? Then you have to go and tamper with the hardware to try to extract the keys. Okay, but you have an isolated software environment that no one is able to download code to the device in order to change the way the device interacts with the host machine. So the host here can make a request of the device, but it can't really dictate how the device responds. So it can't, try to forge something on behalf of the device because the encryption keys are stored within the device. So when you're thinking about a trusted computing, module, it has those particular characteristics. And so typically a server obtains guarantees about the state of a remote client with regards to this integrity measurement, and it relies on cryptographic keys that are held, within the hardware itself.